the screen shared. Okay. So Unit 1, Part 1 review. We're looking at 7 and 8. These are symmetry questions. It says, what type of symmetry does it have, and is the function odd, even, or neither? So what you need to remember is that for it to be an odd function, it has to be symmetric about the origin. For it to be an even function, it has to be symmetric about the y-axis. It would help if I spelled axis with an A. Okay, and then of course it can be neither. Okay, so if it's symmetric about the x-axis or some other line of symmetry, it doesn't matter. It's neither odd nor even. It's only odd if it's symmetric about the origin. That's the rotation, 180 degree, flip it upside down, it looks identical. Or y-axis, that's your line symmetry. You can fold it over the y-axis and everything matches up. Okay, so which type of symmetry does number 7 have? Yeah, if I folded this over the y-axis here, those would align exactly, wouldn't they? So this has y-axis symmetry, which makes it an even function. What about number 8? Okay, so this one actually, I think maybe it was supposed to be odd, but notice how this point is shifted up. This point of inflection, it's not the origin, is it? Okay, so technically, since that point is not on the origin, this would have neither. This would have no symmetry. It does have point symmetry, but the point is not the origin. Okay, so I would say that this is neither. Now, I don't know how easy that is to tell on your picture that that's not on 0. If it looks like it's exactly on 0, then this would have been origin symmetry and it would have been an odd function. I will guarantee the one on the test that asks about that will be much clearer. It won't be so close to being neither versus one of the others. It'll be clear that it's neither. Y'all feel okay about those? Okay. Now, transformations. Okay, these 3 are asking you to write this function of g of x in terms of f of x. So it says you start with the f of x on the left is the original function. Okay, it's been transformed into g of x, and they want us to write the equation in terms of f of x. Okay, so this is not some parent function that we know. This isn't like linear, quadratic, or absolute value. Okay, so we don't need to know that. This is going to be like in our notes when we just put the a, h, and k around the f of x. So we're going to put our minus h inside, or our plus k outside, or our times a outside. This is what our equation is going to look like. It's going to have the f and the parentheses and the x in it. Okay. So for here, g of x from f of x. So this started at the origin and it's shifted over to this point. So that is to the right 2, isn't it? Okay, so is that going to be my a, h, or k? That's your h. Your h is a 2. Okay, now what else? This has definitely gotten taller, hasn't it? It was 4 units tall from top to bottom, and now it's 8 units tall from top to bottom. So that is a vertical stretch by what? It was 4 units tall, and now it's 8 units tall. So what did we multiply by? By 2. It's doubled. Okay, so vertical stretch by 2 and a shift right. So the vertical stretch, that's your A. A is 2. Has this been reflected? No, so no negative in front. Has this been shifted up or down? No. So there's no K. So when I write my equation, it's going to be g of x equals, okay, the A value we said is 2. X minus h, we said h is 2. And no K, so nothing added or subtracted on the outside. So that's a vertical stretch by 2, and that's a shift right 2 because of the -2. Now, does that make sense? So that's what we're doing here. Okay, so we started with f of x on the left, and we went to g of x on the right. This one started at the origin. Now it's starting up here at 2. So this has gone up 2. That's K. K is your up or down shift, your translation. Okay. This was 1, 2, 3, 4 units tall, and it's still 4 units tall. So it's not stretched vertically, but it was 6 units wide, and now it's only 3 units wide. So this is actually horizontally compressed, and it went from 6 to 3. So it's compressed by 2. Okay, it's half the width. It's not reflected, and it's not shifted left or right. Okay, so this is going to look like this. No vertical stretch, so no A, no reflection. H, no shift inside, but the horizontal compression is inside. So that's a 2x on the inside and a +2 on the outside for the vertical shift. You will not have a horizontal stretch or compression on the test. It will just be vertical. So if that confuses you, multiplying on the inside, that won't be on one of the test questions. I know the bell's about to ring, but since I'm recording, I'm going to go ahead and do 11 to finish out this part of the video. Y'all have a good one. Okay, so for this one, f of x, g of x, f of x started at the origin. Now it's over to the right 2. So again, that's our h is 2. Okay, this was a height of 4. That's how tall this shape was. Here it's the same, but it's been flipped over. Okay, so that means A is -1. It didn't change size, it's still 4, but it changed to over the x-axis, so it's negative. The width, let's see, the width, get a different color since there's another transformation, was 6. And now from here, 1, 2, 3, that's only a width of 3. So it was 0 to 6, and now it's 2 to 5. So the width changed. So this is another horizontal compression by 2. So just like the last one. So here for my equation, A is -1. You don't have to write the 1. The 1's understood. Okay, but inside it's horizontally compressed by 2. And it's horizontally shifted. So I've got to have another set of parentheses for that x minus 2. Okay, and then there's no k. So that is definitely the most complicated one of the 3. And again, you're not going to have the horizontal compression on the test, so you won't have to ever worry about those double parentheses on our tests or quizzes. Okay, but that is the end of that video. Be sure to check out the other videos if you need help with other questions on the review.